a new file format, Parquet. Also from Apache Parquet is a file format. Beautiful harmonies with Arrow. I don't want to show you. You can read this as a standardized open source columnar storage format for use in data analysis systems. It was created in Hadoop with systems like Hive, Impala, or Spark, and just a shared standard in high-performance data I/O. It's also an in-memory transport layer. Parquet files. Yes, let's have a look at it. So, as we already seen, Arrow is available as an optimization converting a Spark data frame to a Panda data frame and a Panda data frame to a Spark data frame. I don't have to show you this again. PyArrow is loaded, yes, otherwise we would not have been able to execute it. I use version 4.01. My channel is CondaForge, or you can use Anaconda, whatever. And you simply load it in that way. The Parquet format, PyArrow.Parquet as PQ. And if you want to know if Parquet really activates all your CPU threads, yes, 6 cores, 12 threads, all 12 CPU threads are now activated here with Parquet, with PyArrow Parquet, PyArrow primarily. So first thing we do is we convert from a Panda data frame to an Arrow table. We make sure that it's really a table. The type is really Arrow table. And then we write this table that we have to a Parquet file. I've chosen a single Parquet file, my test Parquet, and flavor Spark because it's coming from Spark. I want to use Spark. And after some time, you will see that a new Parquet file has been created in your directory. I have here my standard default directory where I'm running this Jupyter lab. So the file is over there. 20 seconds. Of course, if you have a Parquet file, you can read with the command PyArrow Parquet, read the table, the Parquet file, and then you can convert it back also to a Panda data frame. This is clear. Now, the nice thing is that if you have converted your data, or you have a view or a table of, I don't know, 100 JSON, your client gives you 100 JSON files, you already created a table, you had a filter operation and whatever, and you saved all this data in a Parquet file, Spark is able with read.parquet to read the Parquet file directly. Now, you have seen that we have done this with the CSV or the TSV or whatever file already directly into Spark. But the nice thing now, if you have Spark, if you read the Parquet file in, it is an unbelievable fast, 183 milliseconds. No? And if you want to check out the size here, is this the small or the bigger Parquet file, the 1.7 gigabyte or the 5.5 gigabyte file? You have with the metadata command, you can see here the characteristics of the Parquet file, the data format. And we have here 157,376,568 rows. So this is the big 5.5 gigabyte file. And to read it in from a Parquet file, it takes about 183 milliseconds. I would say this is a really nice development, and now you understand why people like to use Parquet. Another dimension would of course be data lake, and if you have some other further optimization, and if you look at delta lakes, you will find out that Parquet is something of a common denominator in the file format for data lakes. So display, this is exactly the data frame we know, we love, 5.5 gigabytes, and this is the structure and the schema we defined. You can have now the count command, 157 million rows. This is nice, and if you count it and you define the number of rows and the number of columns. So we see here 157 million, blah, 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 and rows and 6 columns. And the time it took to count all the 157 million rows is exactly 61.6 milliseconds. So speed improvement is significant. And Parquet file 2. Yeah, this is just if I clean up the string. This is nothing special. This is nothing that you might be interested in. Next step, convert Parquet file to Panda data frame. Yes, I mean, of course, if you have a Parquet file, you can convert it to a Panda data frame. This is easily done with PyArrow Parquet. You create a table from Pandas to Pandas. You can write, you can read it. You can have a check at the allocated bytes. This is nothing special. What's really nice is you can write Panda data frame directly converted in a Parquet file. But hang on, there's a catch. Because if you say data frame Panda, so this is your Panda data frame, and you can say, without starting anything of Spark or whatever, to Parquet, test panda.parquet, this is my single Parquet file I want to create. You can define a compression, snappy or gzip. You can define index true or non-true, but the engine is also, as you can see, a PyArrow. So you start again the Apache Arrow for the engine. So more or less, the nice thing is you can directly convert a Panda data frame to a Parquet file, but you have to have Arrow installed on your machine. No problem at all. Runs beautiful on the smallest machine, of even on 4 cores, no problem at all. And of course, if you can write a Panda to a Parquet file, you can read the Parquet file directly to a Panda data frame. And this is the same command you're already familiar with, so no problem at all. What I have here, yes, you can do the count. This is not so interesting. What I think is nice is if you compare now the speed. You remember, if you create a Spark data frame directly from a Parquet file, it took about 40 milliseconds. And if you create a Panda data frame directly from a Parquet file, it takes you about 6 seconds. Of course, this is the mighty power of Spark. If you want, you remember I have, for my 12 threads on my CPU, I have 8 threads allocated of my CPU to Spark. So you can, of course, slightly increase. If you say you allocate 10 threads from your 12 thread CPU, you can play around with this in whatsoever. So again, the other timing that I wanted to remember to show you again, remind us of, if we had a Panda data frame and we counted the rows of this data frame, it took us for this specific data frame 2.4 seconds within Pandas. And if you have now a Spark data frame from a Parquet file and you count it in this optimized version, and of course you have to have a Parquet file that you can apply Spark directly on, you are, instead of 2.5 seconds, you are now at 50 milliseconds operating. And if I was not wrong, this is about a factor 40 to 50 times faster just performing a count operation on a data frame. I would have mentioned a Parquet file format. I personally think checks the future proof of your file format. And if you were interested in data lakes, even then, especially later on in Delta lakes, Databricks with Spark, you will find that the Parquet file is the basis where they built the data lakes and the Delta lakes on. So knowing Parquet is really important, is beautiful to work with. The file size, of course, is much smaller than a CSV file, a TSV file, or whatsoever. And I can really recommend use Spark take advantage of the file format of the Parquet file, perform all your operations in Spark. I have 8 threads of my CPU dedicated to this, and the speed improvements you will get are really, really significant. Please try it out for your specific use case, for your file format. Here, the 2 examples were a 1.7 gigabyte and a 5.5 gigabyte file. And I have experienced up to close to 100 gigabyte here on my Windows PC on a laptop, also running an AMD CPU. 100 gigabyte files on a laptop within milliseconds they perform operation, and it is amazing what you can do with Spark on a single node machine in Python with big data. And again, big data here in our specific use case starts from some gigabytes up to 100 gigabytes. I really can recommend here for your local single node machine Spark, the Parquet file format, and everything else that you want to scale up later on to have a multi-node cluster in the cloud. And you can have it in Google Cloud, you can have it in Azure, or you can have it in Amazon, I don't know, where you run Amazon EMR, Elastic MapReduce, EC2, whatever cloud you choose, you will find Spark is operational over there. Thank you so much for listening, and this is it for today.